Okay, so what we're going to be looking at here is we're looking at two terminologies. We're looking at the terminology of systole and distole. So distal, which we'll start with first, diastole, is when the heart is both the atrium, double, and ventricles are relaxed. And they have to be relaxed in order to allow the blood to flow into the heart. We need the chambers to fill with blood so we can create pressure behind the blood to then eject it. So if distole is in a state of relaxation, we have systole is when there is a contraction, ejection of blood from the heart. Now you can't have the atrium and the ventricles both in systole at the same time. You would have they can both be in distole at the same time, but they can't be in systole. So what we're going to do is we're going to go through step by step of the cardiac cycle just to demonstrate the flow of the blood as it's coming through the heart. So first of all, you can see that these valves here are closed, and if you remember them, we have the tricuspid and we have the bicuspid. So the heart is currently in a state of distole. Both atrium and the ventricle are both relaxed. And this is to allow blood to flow into the heart. Okay, so at the moment you can see that the atrium are starting to get filled up. So my atrium and my two top chambers, they're filling up. But because the valves are closed, the blood is not then flowing into the ventricles. Now what happens is once the atrium have enough blood, they go into systole. So here we have atrium, systole, to pump the blood into the ventricles. And it's actually pumped the last remaining blood into the ventricles. So what happens is that the bicuspid and the tricuspid valves open. You get a systole, so the muscles in the atrium walls will contract and they will pump the blood into the ventricles. And once that blood has been pumped in, you will see down here that the valves shut again. So as soon as that blood is moved, the doors will shut again. And the valves are really important to stop backflow. You do not want blood travelling in the wrong direction around your heart. So we have a period of atrium systole, which moves the blood from the atriums down into the ventricle. And that normally lasts about 0.1 seconds. This systole normally lasts about 0.4 seconds. And then down here, we go into ventricular systole. So the ventricles are now going to contract to pump the blood to wherever it's going. If it's leaving the pulmonary artery, it's going to be going to the lungs. And if it's going through the aorta, it's going to working muscles. That will depend on the type of blood, if it's oxygenated or deoxygenated. So this ventricle systole is about 0.3 seconds, and it is ejecting blood from heart. So the force of the contraction compared to atrium systole is going to be very different to ventricular systole. Atrium systole is just going from the top chamber to the bottom chamber. Ventricular systole is going to be going from the ventricles potentially down to your gastrocnemius, your calf muscle. So it needs a huge more amount of pressure. And also we know that one side of the heart is dealing with blood that's only travelling to the lungs, and another side of the heart could be travelling to any working muscles in the body. So again, that would have very different pressure attributed to that. Okay, So we have whole heart distal, so the entire heart is in relaxation to allow blood to flow into the atriums. The atriums go into systole, so they contract and pump the blood into the ventricles. The ventricles then go into systole, contracting to eject the blood out of the body. Now, the conduction system is an A-level concept. And if you require information about the conduction system, if you can email me directly, it's complex, but it's really, really interesting about how the relationship between the conduction system and the cardiac cycle together. But I will do that on an individual basis. So this is Chapter 1B, Lesson 5, Task 2.